Okay, this is a video about how to use GaussEP, the spreadsheet, for Lab 1, Conservation of Energy. I've copied down a formula onto the data and results page that you're going to have to derive in the lab. You've got to derive this formula, so you get a peek at the answer here. This is the value of G with error that's given in your laboratory handout. And your goal is to find the value of V, theoretical. I should probably put a little TH on there. I think I'll do that for you. With error. So you want to get the value and the error. And the error is the hard part. The value is pretty easy. Just plug in the value of G with its units, and the value of H with its units, and the value of H prime. And in fact, you should do that pencil and paper so that you can check this result. And I did do it pencil and paper. So you've got to use GaussEP. We got a link to it in the lab, but if you're outside the lab, you're going to be using GaussEP outside the lab sometimes too. You would go find your CB Physics webpage. I'm just going to Google CB Physics itself. And then go to first semester downloads, math resources, GaussEP, version 6. So unzip it, then double click on it. Open it, and this is what it looks like. It actually starts out at your name here box. Put your name here. So I'll put Professor Schneck. Hit the Enter key and go back to the start. I'm solving for V. Theoretical, I'm just going to call it V in GaussEP. So I'll double click on this tab so I can change the name of it. Change it to a V, hit return, hit the Enter key. So they used to call the Enter key the return key. So when I say the return or hit return, that means hit the Enter key. And then V goes right there. I hit the Enter key. And so I've changed the name of the thing that I'm solving it for, the two places where it appears. By default, this thing just says F for function, and then the variables that it depends on are x1 through x6. In our case, let me close some of these windows. Our function, V, sub theoretical, depends on three variables, G, H, and H prime. Three values that have some error, G, H, and H prime. So I need a 3 right here, and by default it's set to 3, so I'll just leave that. Normally you have to change that to however many variables you got. Then I want to go ahead and change the names of those variables. So I'm going to double click on the X1 tab and change it to the name of my first variable, which is G. So G, hit the Enter key, change it up here as well. So you can see that this box is already highlighted. So I'll go G again, hit the Enter key, and then I'll go ahead and put the value of G in there, which is 9.80339. 9.80339. Hit Enter, and hit the error for G is 0.405. 0.00005. 0.12345. Hit the Enter key. Now I'm ready to change the name of the next variable. I'll change x2, the second variable. Double click to H. Type in H. Hit Enter. Type in another H. Notice I'm up here now. H. Hit Enter. And the value of H, 0.5800 meters. So in SI units, 0.58, and then plus or minus 0.2. 0.58 plus or minus 0.002. Hit enter again. And now H prime. So I double click on this third tab, or it's actually the fourth tab. H, I'm going to call it HP for H prime. From experience, I've learned if you use the single quote, H single quote for H prime, it doesn't work, or even the H tick mark. So hit enter. Type in HP there. That's the name of it. And H prime is 0.1151 plus or minus double odd 2. 0.1151. Enter, plus or minus 0.002. Enter. Okay, I got all the values typed in now. And now I got to type in the formula that will give V, and I type it in right there. That's where it's going to be evaluated at the values that I put in for G, H, and H prime. And I got to type the formula in. So it's the square root of 2g times this quantity h minus h prime. The square root is represented by SQRT. So I'll go SQRT open parentheses. And then if I don't make any mistakes and I just keep on going, I can take advantage of something. So first it's 2, and then the time symbol, which is a star, and then G. Well, I need the actual value of G. I needed to access the value of G, which I typed in over here on this tab. So to make it enter, I don't have to type it in. It'll automatically type in if I click on the right cell in Excel. And I'm going to click on that one right there. And I would say that may or may not have worked. Let's then go times, because I'm going to be multiplying the rest of that. So I'll go star, and it did not work. So I'm going to start over on that. So I go back to this cell. I go delete. I forgot the equal sign. Every function begins with an equal sign. So equals. So anytime you type in a function, you got to start with an equal sign. Square root of, and it was kind of nice it wasn't working. That told me that I had some kind of mistake. So it was 2 times, and now I'm going to try clicking on that G value. Boom, boom, and you can see it's just adding up. It just put in the cell name, actually. It's A2 in page G. So worksheet, I think they call it worksheet G, exclamation point, cell A2. And that put that in there for me. And the next thing I needed after the G was times, and then open parentheses H. So star for the times, and H, open parentheses, and then H, which is over here. There's the worksheet for H, and then the actual cell. So it typed that stuff in for me automatically. And then minus H prime. Here's H prime. Click on the tab. So I'd already put the tab bar in there, and then the exact cell, and I got H prime in there. Close parentheses. That ends that parentheses, and then I got to end the square root, which started with an open parentheses in the Excel format. So I got to type in a close parentheses. And then I'll hit enter, and that has changed that value, and it gives me the same thing I got when I did it, pencil and paper and using my calculator. Alright, so I've actually got the formula typed in there, and now I got to type it into these other 1,000 locations, or I got to copy it. Let me give you the idea. Anytime you got to measure something, all you're really doing, the best you can do is find a distribution. You can't get some exact value from a measurement. So either you take 1,000 measurements and figure out what the distribution is, or you take one measurement and based on knowledge about the measuring device, you give it an estimated error. You establish an estimated error. Rule of thumb is the error is half the smallest division on the device you're using to measure it. That's the rule of thumb I used. In such a case, you have to be careful to estimate that last digit between the two smallest marks that you can. So for instance, over here, It's turned out to be 00, but this was 11.51 centimeters. That would be it's marked off in millimeters, so I can actually see that it was the 5th tick mark. So 11 big ticks, 5 little ticks, and it looked like I was a tenth to me, my eyeball. If I were making the measurement, the Schweitzer actually gave me these values, but if I were making the measurement, this would mean that my eyeball judgment was that the actual end, or the actual distance that the dot was above the table, where it lined up with the ruler, was just a little bit, 1/10 of the way to the 6th tiniest tick mark after the 11 centimeter mark. And so that represents an estimate. As long as you do that, the rule of thumb will work for you. Just don't be rounding stuff off as you take the measurements. Get it as precisely as you possibly can, including estimating that last digit. So what this graph represents is how many, given that the distribution is what they call normal or Gaussian, how many of them would actually have the value of 198? How many of them would have the value of, how many would have the value of 1.1, or the actual given mean value? How many are a little bit above that at 1.15? How many a little bit below that, 1.05? You can see the number popping up just below it. And the further away you get from the mean value, the smaller of those imaginary 1,000 measurements you would take would have that particular value. So all the way up here at 1.3 compared to the 1.1 that is the mean value roughly, we're getting very few of them. The bar graph is short. The bar for that position is short, so we got very few of them. And you can see that what the GaussEP does for you is randomly pick 1,000 values with the probability given by this curve over here, and you can see that in the end it actually fits that curve of those random numbers. It fits it remarkably well in this case. But then once you get 1,000 values for the our x1, which is actually g at this stage, 1,000 values for h, and 1,000 values for hp, it picks one from here, one from here, one from here, and calculates what the v is, and then repeats. And it does that 1,000 times, and then you find out how many of them fall within a small region of this value, the 7.99 value. How many fall within a little region of this value? In the case at hand, where I'm looking at these numbers, it hasn't done the calculations yet. I haven't updated the spreadsheet, so these numbers aren't the actual numbers that we're going to wind up with. But the point is, in order to do these 1,000 calculations, I need the formula in these 1,000 locations, like from here all the way down to here, not just the one location where I was calculating the mean. So what I got to do is copy this. I'm going to go Edit, Copy, and then I got to paste it to these 1,000 locations. I'm going to click on the first one and release the mouse button. So I'm not clicking and holding, slide all the way down to the bottom. Hold down the Shift key and click on the last one. That selected all 1,000 of those, and now I just have to go paste. And it's copied the formula down to all those locations. Let's look to see if we got the actual formula rather than some number. And then I've got this spreadsheet set so it doesn't calculate every time you change the number, because it's got so many calculations to do it can take a while. So what you got to do when you're ready to see the calculation is press the F9 key. So I'm going to hit F9. And sure enough, it's changed all the numbers, and now these numbers really do make some sense. Now this middle one, the most likely one, is right about where I calculated it. So it completes, it finds how many values you get in each one of these, creates the histogram, the bar graph, and then does a fit of the Gaussian to it to find out what the width of this curve is, so that it knows what to put down for the error, and we call that the standard deviation, and there it is. So these are the actual numbers that go in there. I'm going to carry the the standard deviation, you should keep that to 2 or 3 sig figs, so I think I'll go with 2, so the 9 and the O, and of course I need the placeholders as well. And then write the number above to the same number, to the same decimal place. So I'll go 3.0191 plus or minus 0.0090. That'll be my answer for that one. So let's see if I can just write that in there. Go. Point, probably not because I don't remember it now. 3.0191. It's a decimal point, not a comma, and it was 0.0090. So it'd be my answer for that. As far as what you got to print out when you do this, I'm going to select the region that will include all the relevant graphs. So I clicked in that upper right corner, and then I'm going to do a shift click. Hold down the shift key and click on that. I don't need these graphs because they're not being used. And look at that. In this graph, it said there were 2 values outside of the range that I wanted to use, just a little bit beyond there. So we got a pretty good representation of what the distribution looks like. And then I'm going to do Control P to print it. That's what I'm used to hitting for printing. And I'm going to do a preview. And I see it didn't all fit on there, so I'm going to do a setup. I didn't show everything that I wanted. Go landscape. Try OK there. I'm a little bit worried. Yeah, I got way too many pages. So try set up again. And I think I'm going to go back. I'm going to close this print preview, and I'm going to go back to Control P and say print what? I want to print the selection, just the part that I highlighted. So it's pretty critical to pick the selection. Then I'll go Preview, and now it's looking much better. It looks like it all fit right on there, and it looks like I got no more pages, so if I hit page down I don't see anything. So I'm not wasting a lot of paper here, just one printout. It's got the G value that I use, the whole distribution, the H and the H prime, and it shows what the V is, and I can actually read these numbers on there, so they're kind of all the same. So I think I want to change the precision of these numbers so that they don't all look the same. So I'm going to go number format, and I got numbers. I'll go try 3 decimal places. See what that looks like. Okay, and it automatically changed the angle of the numbers, and now I see actual different values. So the center of this region is 3.019. Center of this one is 3.024. And I think we're in pretty good shape for printing it out now. So I'm going to make that selection again. Shift click down here, and then do a Control P. Print only the selection. Do a preview. It's in landscape mode, so I'm getting everything that I want, exactly what I want, and then hit the print. And you guys have to hit print a couple of times because you got a couple of so you need one for your lab part, or change the number of sheets there. But so if I were to do Control P again, get back to that. This is that's the second one right there, and then you need a third one. Well, depending on how many in your group, you probably just need 2 if there are 2 in your group. So we'll call that a wrap for